Alright, welcome. Today in chemistry, here's what we're going to be taking a look at. Molarity practice problems. So in the previous flip video, we talked a little bit about molarity, how to calculate molarity, and problems dealing with molarity. So here's what I got. Practice problem. Calculate the molarity, capital M, when 610.00 grams of potassium nitrate, KNO3, is dissolved in 2.50 liters of solution. You know the drill. Take a stab at this, try it, and we'll go over the answer together. All right, let's see what you did. How did you match up? So we know our volume, which is 2.50 liters. That's the volume of our solution. And we're given the grams of the solute. Right? KNO3 is our solute. So we simply have to take the mass that they give us here, the 610, and convert that to moles. Okay. So let's take a look. Our solution. For our solution. Okay. Moles of solute divided by liters of solution. So the first thing I did here was I divided the mass of the solute, KNO3, by the molar mass, MM, of potassium nitrate. And we get, sticking to sig figs, I get 6.0330 moles. I know my numerator, my number of moles. I know my liters of solution, which is 2.50. I simply divide the two and I get a molarity of 2.41 molar. Once again, what does that even mean? Right? If I were in a laboratory and I saw 2.41 molar KNO3, what would that tell me as the reader of the label? That molarity would tell me that there's 2.41 moles of potassium nitrate for every 1 liter of that solution that I use. It's a concentration. All right. Trying to do two at once. That's not going to work. Oh, there we go. Okay, problem number 2. 100 milliliters of a 5.55 molar solution of magnesium bromide has been poured into a beaker. How many moles of magnesium bromide are dissolved in the 100 milliliters that you poured? So in other words, we have our solution, which has a concentration of 5.55 molar MgBr2, and from this stock solution, our original, we're going to pour out in a separate beaker, 100 milliliters of this solution. So the question asks, how much of this MgBr do you have in that 100 milliliters? So the solution, all right. So they give us milliliters, right? And we know that molarity is expressed in liters. So I need to move that decimal 3 decimal places to the left to get liters. Okay. So this is what we poured, right? That's 100 milliliters. Okay. And my molarity is my concentration. That 5.55 molar says that I have 5.55 moles of MgBr2 per every 1 liter of solution. So I don't have a liter, I have 1/10 of a liter. So my liters cancel, and we have 1/10 of our concentration. Right? We have 0.555 moles of MgBr should be in that 100 milliliters of what we poured out. All right, our last two slides, our last problem here. 4.50 liters of a 2.10 molar solution of sodium chloride table salt has had 200 grams of sodium chloride added to it. What is the molarity of the solution? So we have a solution, we know the concentration, but yet we've added moles of solute, grams of solute. What's the new molarity? Let's see how you matched up, okay? How you compare to what we have. All right, our solution. Okay, so in orange here, here's my molarity, right? 2.10 moles per 1 liter, and the total volume is 4.50. So I take my molarity, and I multiply it by my total volume, and this tells me how many total moles of sodium chloride are in my 4.5 liters. Right? But someone comes along and they add 200 grams of sodium chloride. Well, we have to know how many moles is that 200 grams. So I take 200 grams of sodium chloride divided by the molar mass, which is 58.44, and we get 3.4223. So that's what's added. So if our solution had 9.45 grams already present and someone added an additional 3.4223 moles, I take the sum of all my moles and I get 12.87 moles of sodium chloride. That's what's dissolved in our 4.5 liters. So I take my total mole amount, 12.87, divided by my volume, which hasn't changed, and our new molarity is 2.86, right? Which makes sense, right? If you think about it, our original molarity was 2.10. We added more solute, we increased the concentration, and it went up from 2.10 to 2.86. All right. As always, with these flip videos, if you don't understand it the first time, watch it a second time, or who knows, maybe even a third time, right? If there's anything in here that you don't understand, as always, raise your hand in class and we'll hopefully answer your question. All right, guys, until next time, good luck with this and keep on practicing stoic, or in this case, molarity, which is related to stoic. All right, this is becoming awkward. Have a good day.